In this episode, we use the no mentation without representation principle to examine the symmetries between minds and computer algorithms. Welcome to the Bottom Turtle Podcast. Hey everybody, and welcome back to the Bottom Turtle Podcast. I'm Dr. Shannon Ray, and we're joined by our co-host Oyani Onemiya. How you doing, Oyani?
I'm doing okay, Shan. What's good? What's going on, man?
Man, just things are good. I was actually going to ask you how you were doing. I want to know how you're doing starting off. How's work?
Yeah, I'm doing okay. It's the end of the year, so I'm trying to work on putting together my portfolio for 2020. Some of the work I did that I really liked and things like that. Kind of put it in an editorial of sorts, so I can always look back and kind of reference, where I was last year. I try to do one every year.
Oh, for real?
Yeah, so I'm working on that.
I didn't know you did this.
Yeah. It's kind of my way of keeping track of my progress, essentially.
Yeah.
So
I don't know. I like hearing all the different ways you go about constructing your business, like when it comes to pricing and how you check your progress and all this stuff. I don't know.
Yeah, because I don't know. I feel like it's necessary for you to be aware, of how much better or how much worse you're doing in anything, so you can, make changes and kind of, reconfigure as you go along. So, I'm working on that.
I don't know. I just think it's cool because you're pretty much building this foundation from scratch.
Yeah.
You're literally just starting off like, all right, you had this other job doing the airplane stuff. And then you're like, you know what? I don't want to do this job anymore. And you just quit. And then from nothing, just like, I'm going to teach myself how to draw. Then I'm going to teach myself how to advertise my stuff. And, I don't know. I just love hearing about how you go about doing it.
For me, it's just more of a satisfaction thing. Like, I feel like I need to create things. Like, I need to bring things into existence for me to feel like any of this has any meaning. Like, it's just like...
Yeah, I know exactly what you mean.
What's the point? What's the point if we're not bringing things in? And,
That's actually one reason why I stopped playing video games, although I might have went too far with it, because, when I was younger, I used to play, like, I would get, like, Team Fortress 2 on Xbox 360 when I was in college or something like that. And if you looked at the number of hours I'd play that game, it was just ridiculous, man. And you dump all this energy and time, and you get really skilled at this game because, let's not get it twisted. I was dominating people in that game, because I played it so damn much. You can't do something for so long without getting better at it. But came a point where I would start getting into another online game and like, all right, I have to learn like this map where the weapons are, where the med packs are, and I got to refine my skills. I got to come up with strategies. I got to get with all the characters. And after a while, you're just like, when you're done with it, you've spent all this time consuming someone else's art. But there's a certain point where it's like, okay, I'm 34 now. I've done this enough. Now it's time for me to start creating. I have to create now.
I think everyone should strive to create something. It doesn't have to be art. It doesn't have to be anything major, but you need to like add something, into the pot, so to speak. Like, it's weird to just, take out of it and just consume out of it.
Yeah. Well, it's interesting that you say that because, like I said, I was in awe in your structuring of your business and your progress. And I know we've always had these conversations about, you have this mentality that you do something long enough, you'll get good at it. But you always say that because that's just how your mind functions. Like, if you do something long enough, you'll get good at it. But I always bring up the fact that only depends on whether or not you are slowly improving over time. Like, someone can start at some point and just spin around in circles, and they can be doing it forever. They aren't going to get any better.
Is it possible for you to not be improving your process as you go along? Even if it's something like, okay, I'm going to find a shortcut to do this. Instead of clicking here and here, I can click here just one time and get the same thing done. Like, that should be part of your process. I think yes.
You can't comprehend that someone not having that as part of their process. That's the thing, though. But it's like, and this is actually something that is going to be brought up in today's episode.
This is today's episode.
The idea of when trying to, huh? I know that's the one thing that we're bringing up. But I'm saying, we're going to talk about in the episode.
You're making it seem like the episode is coming down the line. Like, we are in the episode right now, so we're talking about it in the episode.
I know. I'm just saying. Man, I don't know how you defend me on this, but But the thing is I was just saying, I was just trying to give like a
No,
sneak
because
peek of what people
but
will
the reason
see
why
in this episode now.
I would have wanted that you did not do that was because I wanted that we could just go into the episode from all of this. So by saying, "Oh,
Yeah,
this
but
is
the
something
thing
we will talk about in
is
the
I feel like,
episode," is like we're in the episode already, though.
well, that's the thing is I feel like I'm trying to connect what we're saying now with what we're saying with a larger picture down the line. And so I'm trying to communicate like, yeah, here's this idea and it
Hmm.
doesn't seem as though it's connected to what we're talking about, but later this idea is going to be viewed from a different perspective later on down the line
Yeah, because I
based
just
off of what we're
assumed that
saying now.
we were just going to go into the episode from there. There wasn't a okay, let's start the episode type of thing.
Well, that's the thing is, I think there's a fundamental disagreement between you and me on this because if you notice in each episode, I always do say something like, and this is something we're going to talk about this episode. And the reason why I do that at the beginning of the episode is I want people to understand where they're going. And that's one thing that I've noticed when writing papers, like, writing all these, academic papers and stuff. One of my favorite papers that I've ever read is one where they always tell you what they're doing and why. And so they tell you up front, okay, this is what you're going to be expected to think about. And then that gives you prime to go, all right, that's what I need to focus on. And then as they start presenting it, you know why they're saying what they're saying, as opposed to having to sit there and wait and then find out what they're going to say.
I appreciate it better from the other angle, though. I appreciate it better from, now I get it. As opposed to, because I feel like, for example, we want to talk about um, cars, for example. Say we want to talk about cars in the episode. So we open
Hmm.
up the episode and we're just talking about something that's seemingly not related, and slowly but surely we start to guide the listener towards where we want. Like I almost feel like that is a more okay. Let me kind of explain how I always envisioned this podcast from the beginning. I always envisioned this podcast as
Yeah.
how we have our conversations. Nothing any different. So it's like when we talk, we never actually make, because a lot of these things that we are talking about, we've talked about this before, but we never had like a specific, all right, Oyani, you know what? Right now we're going to talk about blah, blah, blah. We just talk about stuff, and slowly but surely we just end up with a specific topic related to the general idea.
Yeah, but another thing we don't do when we have our conversations is create outlines. You know what I mean? Like basically what I'm saying is that what we're doing now is fundamentally different than what we do when we're just chatting. And what I'm trying to say is that like I feel like I'm on board with you and trying to make this
Mm-hmm.
feel as much as our conversations as possible, because I feel like, we're trying to make this conversational so that people can relax and feel like they're chilling
Mm-hmm.
with us as we work through these ideas. And I completely get that vibe, and that's what I'm working toward. But I think that fundamentally it is something different. And so this slight tweak of just like a little bit of a nudge of like, oh yeah, and by the way, this is kind of the theme of today's episode said at the beginning. It allows people it prevents them from getting lost. And it makes the information more, it's like hanging a carrot in someone's face. And then now that they have the carrot in their face, they want to know what's going on next. Whereas if you don't give them the carrot, they're sitting there going, okay, what's going to happen next? Like, oh, and then they get that,
Yeah,
but that might
are you
lose people's
saying
attention.
that in all other forms of art where this is how the approach is, like, you watch a regular movie and it's not like they break down the entire plot in the little blurb. You read the blurb, you kind of get what it's about, you keep it going, and then you kind of find out more as you go along. I'm not saying that your idea is completely wrong or I don't like it. I'm just saying the difference with how we envision it is probably where we are now, because I'm seeing it as, yeah, we're just talking about something and then we're just slowly but surely going to talking about optimization algorithms and things like that.
Well, that's the thing. I think it does. It's a matter of a difference. I mean, because it's definitely not an objective difference. There's no objective right or wrong answer to this, and it's definitely a matter
Yes.
of what are we trying to optimize? What game are we playing? What's our objective function? And the point is that for me, what's important is communicating these ideas to people. And so for me, I feel like just like we say before, when someone's creating a movie and they have a concept they want to communicate. If they just beat you over the head with it, then no one wants to fucking watch that movie. Like, it's just a terrible movie. You have to actually pay in the emotional simulation that someone will have to go through. You have to get them emotionally interested in it. And so for me, I just feel like I'm willing to give up that piece a little bit because I have so much resource that I can put into one thing or another. Getting the concept out and expressing the idea, or the emotional journey. And I feel like I'm taking just a little bit off the top of emotional journey to put into the other one.
Yeah, so it's not like, it's not a, you're wrong or right thing. It's just a two different approach, I think, yeah. But you are right, yeah, because essentially you're taking a little bit off of that emotional part and putting it on there. Say, hey, this is exactly what I want you to get in your head. Don't miss this part, yeah.
Yeah. Because the thing is honestly, when I'm looking at this at a bigger picture, the thing is that revelatory thing that you're looking for when people like kind of go through these emotional swells once they comprehend something, like having the murderer revealed in a movie, like, and you get like that feeling. Do you know how many of these things that we've just implanted throughout each episode? Because the whole point with this podcast, like with the first episode, for example, I feel like people are like, oh man, I liked the first episode, but when the main feedbacks I got is you didn't define everything well. So like, there's a lot of things that are just said, but they're not really well defined. But the thing is the purpose of the podcast is to build up enough correlated structure that there are these voids of understanding. But as the structure gets larger and larger, eventually those points are going to be filled in. So even if you didn't understand everything in the first episode, eventually, if you listen to us long enough and we're able to build the entire conceptual space out of information, that hole is going to be filled. And when it does, you're going to be like, just like you would be surprised of who murdered who in a movie or something. And so we're doing that all over the place anyway.
It's not your approach is not. It's not like it's horrible. It's just something that my imagination was, once you went through that process of, hello guys, welcome to the podcast, blah, blah, blah. We were already going. So all you had to do was just slide into the topic from this bullshit conversation we're having to begin with. That was what I was, okay, slide right in and just take it from there. And maybe it's just me feeling like we are that good to where we just bam, 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 boom, and we just go right to the beginning of the outline and just start going. So, I might be overestimating our prowess here.
Yeah, I don't know. I mean, it seems like it's informed by our experiences as well. Like I said, I read a lot of these physics and mathematics papers, and and when they're written like shit, man, it's painful. And the worst thing that makes them the most frustrating is where it's like, why am I caring about this? Like, what? Because that's the thing. I don't want to have people starting off in the beginning of the episode with us building up into the episode, and then someone going, why am I caring about this right now? And instead, it's like, or here's why you're caring about this, because this is going to tie into computer algorithms later on. And like you said, it definitely is a matter of preference, but I don't know. I don't know which is better. But I can't remember. I can't remember. Oh yeah, the reason why I brought that up, your process. So your process for because we're talking about how if you do something long enough, eventually you should get good at it. And the reason why, like I've always argued that that's not necessarily the case, is if you don't know what game you're playing, you are just gonna bumble and walk in the other direction. Like if you say in your mind that you're trying to accomplish one task, but everything you do moves you further away from that goal. If you don't define the goal and you don't actually know what you're trying to optimize, what objective function you're optimizing, what game you're playing, then you can spend a significant amount of time not getting better at it because you actually don't know what you're doing.
I definitely agree. It's just, I think for me, my biggest struggle was just, I can't imagine bumping my head on a wall that hard continuously and not realizing, like, wait a minute, son, you're so far away from the goal here. So if I see, if you go online, for example, you'll see all kinds of designs that, designers do, especially people, designers in like Europe and, all over the world. And there are design communities where you can go on and see some of their work. And of course, I look at some of their work and I know, I like that. But that is almost like me watching Israel Adesanya do like a backflip or something. I mean, it's cool and all that. But as much as I am starting to get into martial arts or whatever, I'm not quite there yet. So now
Yeah, yeah.
if I decide in my head that, you know what, the goal is to
It's to do a
do a
backflip.
backflip, I'm
Yeah.
not going to start to learn how to fry chicken and think I'm just like, okay, you know
Yeah,
what?
yeah,
Yeah,
yeah.
okay,
No,
now
that's
for now
exactly
I
it.
can only jump so high, so I'm gonna work on my jumping. Okay, for now I'm gonna work on my
Yeah, yeah,
stretches. So
yeah.
now I'm gonna combine my jumping and my stretching. It's a rotation. So I'm working through the process of putting those things together to get there. But
Yeah.
I am finding it hard to believe that in your process you see the goal, in your process to get in there, you stop along the way and you're frying chicken for like weeks on end. You should know by now that this is not helping you learn how to do a backflip. Do you,
Frying chicken on weeks on end. Yeah, but that's the funny thing about it is whenever you're playing a game like backflipping, that's so tied to the physical that it's hard to mistake the goal.
Hmm.
It's like if you're playing chess, the rules of chess are so obvious and clear. It is hard to not understand. It's hard to mistake whether or not you're working toward your goal. Are all your pieces getting captured and you're getting no board advantage? Then you're not reaching your goal. Like
Yep,
it's
yep, yep.
obvious. But when it comes to mental activities or something as deep like I'm going to build a
Yep, yep.
business,
I see what
now
you mean.
the goals start becoming less
I
clear,
see
and
what
this
you
is
mean.
one reason why we want to talk about the conceptual space as an actual space because it helps you
Yep.
be on target. It helps you think about where you're trying to go and
Yeah.
where you are. And I think that what another reason why people mess this process up is what they want is the feeling of accomplishing the task. So they want the title
Yeah.
or they want the trophy that comes along with the accomplishment. And so and so instead they're focused on that as opposed to focus on the actual goal. And so they may be, it's just like when you ask someone, these people who come and ask you to make something for their
Mm-hmm.
brands, like they have a brand, they want you to make a brand thing and they want you to use their face or something like that. And for you, you're thinking, okay, you're in the
Yep.
marketplace, you're trying to get your product out there, and there are certain color patterns depending on the
Yep.
product you have. There are certain shapes
Depending
that
on
you
the
want to
market
use
you're trying
depending
to
on your
reach.
demographic. Yeah, this is what you should be focused on. But instead, in their mind, they're focused on the dream of building some brand with their
Yeah.
face on the middle of it. And so it's like if you're constantly trying to optimize that game of
Yep.
essentially projecting your vanity, then the actual game of the work to
I
actually build this
100.
thing,
You
you're
are
never going to get any
100%
better
right.
at it.
Yeah, that makes sense. I can
Yeah,
see now how someone could get lost in that space and
yeah.
not realize that you're going further and further away from the goal. That makes a lot of sense now. Yeah, it definitely does.
Yeah. Or and especially if you lie to yourself. Like for example, say that you try to accomplish a goal and every time you fail, you blame it on something other
Yeah,
than yourself. Then you can consistently do the incorrect thing over and over and over again because you're never being honest as to why you're not being
I
accomplished.
definitely agree. Yeah, yeah, you're right.
Yeah.
I think this is actually the first time I can now kind of see how someone could be so far away from the goal and not even know it. Yeah.
And not get any better. And this idea of the goal and how you reach it, it kind of has to do with what I talk about, like gradient descent algorithms. So the thing is one way that motivated my
Mm-hmm.
conceptualization of like these abstract spaces as actual physical spaces is working on optimization algorithms. So when I was in grad school, I had like it's funny because I feel like my PhD itself, the
Yeah.
topics I worked on, the first one wasn't even physics. It was just all mathematics. It was like computational geometry, 100%. The second one was physics, but to actually do the calculation, I had to do an optimization of that Wang and Yao quasi-local energy functional. And so essentially my PhD is broken up into two optimization projects. The first optimization project was on a multivariable function, and the second one was on a
Okay.
energy functional. So they're two slightly different concepts, and so I want to focus on the first one, which is optimizing a multivariable
Okay.
function. And and so when you're optimizing, you have this space of parameters. So you have this space of parameters, and you have this function. In this function, it takes in the input. So the parameters, so say I have 3 different parameters, and each one of these parameters can have different settings. So I'll call the first parameter X, the second one Y, and the third one Z. And say that X, Y, and Z, each one of them can have a value between 0 and 1. And so, I can set X to equal to 0.2, I can set Y equal to 0.6, and I can set Z equal to 0. That's one setting of the parameters. I take those parameters, I put it into a function, and then the function gives me an output. And the output depends on the setting of the parameters. So maybe if I pick 0.5.7, and the function will output 8. Okay. And then I put in some other values and spits out 3. Well, 3 is less than 8. And so I'm trying to find those parameters, those inputs that give me the smallest output. And that's essentially what optimization is, And so when you think about those 3 parameters, though, you think about the set, when you think about the set of all the values they can have, that set, each setting is essentially a vector that tells you a location in the space of parameters. I can be at one location, like the point 0, 0, 0, where I set X, Y, and Z to 0. That is the origin of that space. Then I can set, 0, 1, 0. Then that's and so you have this space of parameters that emerges. And given that space of parameters, you can imagine that the output of the function is a height. So instead of using 3 parameters, let's use 2. Let's use X and Y. And so say that I have X and Y, and I have I choose some value of X between 0 and 1, I choose some value of Y between 0 and 1, and then the output is like a height. So you can imagine a plane, like your table. Imagine you're looking at your table right now, and that table is like a flat 2-dimensional plane. And imagine that for every point on the table that you're staring at, there is some height associated with it. And if you take the collection of all of those heights, then you're going to have a surface that emerges from all of those heights.
Yep.
Yeah, and so in this case, what you end up having is that the function itself defines the surface. So if it takes in these values, it spits out this height. If it takes in this value, it spits out this height. And the collection of all of those heights then define a surface. And so when you're looking for when you're changing the values of X and Y, you're changing the values of the height, and you're trying to find the lowest point. And so in this example, when you're optimizing, trying to find the lowest point on this surface defined by the function, that is you trying to play the game of getting your business working, right? So you're trying to play this game where you're trying to find winning the game is finding the lowest point. And so you're just like going, okay, I tried this, I attempted this first thing, and it gave me this result. And so now I'm going to try tweaking it a little bit more, and now it gave me this result, and this result looks a little lower, as a lower height than the other one. So then, all right, I think I'm going in the right direction. And so you're constantly sampling the height as you're taking these steps.
I think it's so obvious, though, how important being able to understand how to optimize even in everything you do, your everyday life, and just to access the space of ideas, because there's always how I see optimization from a visual designer perspective is it's at the core of everything that you have to do to create stuff for people.
Yeah.
Yes, it's at the very core, because,
We have no idea how deep that statement is.
Oh, yes, it
is. No idea how deep that statement is.
And so it's interesting because, for me, if I have a project I'm trying to complete, first I'm trying to understand exactly what this brief is. So I get a brief from a client, and they're like, hey, this is what we want to do. They give you a little spiel about what their business is about. They give you a spiel about what they're trying to achieve with their business and all of that. I'm going to read that and fully digest what they're trying to say. And then I start to search within the space of ideas. And again, in this space of ideas I'm searching in, I can't search all of the ideas. There's always a constraint to it. And then I'm stuck in this. Okay, so this is the space that I have to search in. I'm searching in there, and that process for me, I call it my ideation process. So I'm sitting there and I'm just searching. I'll go back, I'll read the brief, I'll search, and then I get into the process. Okay, let me start to execute something. So I get my pen and paper out. I'm drawing, doing a trial by error, going back, going forward. And every time I come up with an idea, I look at it. Okay, based on the goal that I was trying to achieve. Maybe, for example, I'm trying to pick colors and typography for a children's book.
Mm-hmm.
Now I'm thinking, okay, I don't want to use a script font because, kids can't really read that.
Yeah, and just as pointed out, like these choices, like, all right, the fonts you use, the colors you use, these
Yeah.
are your parameters. These are like changing the
Yes.
values of X and Y.
And so,
because X and Y can represent anything. Insert concept here.
and that's kind of where I was getting at, is this is something that is so obvious in our everyday lives, and we just need to just take a moment and observe how important it is. Dude, we don't even need to go that far. Something as simple as a crossword puzzle is a perfect example.
Yeah.
You get a crossword puzzle has so many spots for you to put the letters, and you have the option. You can have an option as something like a pirate's cry, for example. It's just a one down pirate's cry, and you think, okay, this is a 4-letter word or a 5-letter word or something.
Yeah.
What could it possibly be? You're in this space now. This is the space you have to search.
Constraint.
This is the space.
Yes. Now, and
go ahead.
Yeah, and to piggyback on that point, because I didn't want to lose the thought. But when you keep saying like you're in the space, this is a constraint. You notice the language you're using: space, constraint, space, constraint. The idea of spaces as being defined by constraints is exactly how we do it in mathematics. Like, think about the equation for a circle: x squared plus y squared equals r squared. What that means is that I have that plane, like I was saying before, of x and y. Like, imagine your table is the set of all values x and y can have. All real numbers, all values of x and y. And so, without any constraint, and you give someone this set of x and y, they can pick anything. It's like, all right, they pick anything. But then when I say, okay, instead, you can only pick x and y such that x squared plus y squared equals r squared. And then if you change the value of r, that changes the radius of the circle, so it changes the size of the circle. But what that's saying is that if you have like 0, 0, x equals 0, y equals 0 as being the origin, so that's where the circle is centered on, then every single x and y you choose has to have equal distance from that origin, and then that creates a circle. The constraint equation of a circle created the space or the geometry of the circle. And this is how geometries are defined. You have some sort of constraints. You place those you place those constraints on a set. You have a set. You place those constraints on it, and then every point on that surface that satisfies those constraints, they all have the symmetry of satisfying that constraint information. Every last point on that circle is equal distance from the origin. That is the symmetry between those points. Yeah. And so this inherent structure, this inherent geometric structure that arises from parameters and constraints, is essentially the space that your mind is working in, because here the parameters are the settings of your configuration. And so you're navigating the space of configurations when you're thinking or you're using your mind.
Because I think that even in something as simple as, popular apps that we use, it's so obvious how there's a whole lot of optimization that's constantly going on in a bid to achieve a goal for whoever is sponsoring this app. It could be make as much money as possible. It could be, we're not even arguing now about what's the right thing to optimize for or whatever. You could optimize for anything. And that's the beauty. I think that's one of the things that we talk about, is that's the beauty of how we are as human beings. We can go around and just optimize for all kinds of stuff.
As minds, especially, as and that's the funny thing. As humans, we seem to have more degrees of freedom, like more freedom to choose what we want to optimize and what we don't want to optimize. That's like, as both cats can only do so many things. But one thing I want to point out is the what you choose to. So remember, the functions themselves, or the constraint equations, in optimization we call those objective functions. So you define an objective function, which is the, like we were saying before, you have the parameters that you put into a function, and then that gives you an output. That objective function determines what game you're playing. It determines the geometry of the space you're navigating. And in the case of the adiabatic isometric mapping algorithm, the purpose of that algorithm was to take a geometry made of triangles. So I have this geometry made of triangles. Think like a tetrahedron or something like that. So I have a tetrahedron, which is a polytope. And I can give it, so a tetrahedron itself, for anyone who doesn't know, those are four triangles
Each
glued
other.
to each other. So they have
Two,
there's
three.
four
Yeah,
triangles
four
glued to
sides.
each other to make a solid space, a solid surface that contains some volume inside of it. So it's a, yeah. Anyway, you can Google it. Look up a tetrahedron. It's easy. And so say that given that tetrahedron, each, there are different edge lengths of the triangles. And so the settings of the edge lengths determines what the tetrahedron looks like. I can change this size, I can change this one. And so given the length of all the edges on this tetrahedron, I'm trying to find coordinates in three-dimensional space, so that when I take the coordinate of one vertex and the coordinate of another vertex, and I use those coordinates to compute distance using the Euclidean distance, or the Pythagorean theorem, essentially, I'm using that to compute distance. That distance that I compute using those coordinates in three-dimensional space, they have to equal the length of the edge. And so that is the constraint that I'm trying to satisfy. I have all of these. So basically, I start off with a list of triangles by vertex. So it's like, okay, triangle 1 is vertex 1, 2, and 3. Triangle 2 is vertex 1, 2, and 4. So and then that makes another triangle, and those two triangles share the edge 1, 2, right? And so that is all the data I have. I just have a list of triangles, and then I have a list of edges and the length in between them. And then given that data, I need to find a set of coordinates in three-dimensional space such that the distance computed in 3D equals those lengths. And that itself creates an objective function. And so in this case, the variables I'm looking at are these three coordinates that are three. So for each vertex, there are three coordinates. And so if I have a surface that has 5 vertices in it, then that's a 15-dimensional space, because I have to have the x1 for a vertex 1. I need to find x1, y1, z1. For vertex 2, I got an x1, x2, or whatever. Yeah, and so that in itself creates the what was I saying? Yeah, so the space I'm optimizing in is 3 times the number of vertices of this geometry I'm trying to embed, is what we call it. And so the way that we create the objective function is we essentially take the square of the edge length, and then we take the, x squared plus y squared plus z squared, essentially is how you compute the distance, and we subtract those from each other. And for each edge, all of those should equal 0, because if I take the length of the edge minus the distance computed in Euclidean space for the 2 vertices, if I take the difference between those, it should equal 0, because that's how I know that the edge length is equal to the distance to the distance as defined by these coordinates. And and so I create my objective function for every single edge, making sure all those are 0. So if I choose x, y, and z for all the vertices, and I plug them into my function, then my function should output 0. And if it outputs 0, then I know for a fact that I found the lowest point on this surface that has, a dimension equal to 3 times the number of vertices. And so the space I'm optimizing in, when I was doing this, I think the largest one I embedded had 3,200 vertices. So that's a 9,600 dimensional space that I have to write this algorithm to search in this space to find these parameters.
Yeah.
Yeah, that's what the algorithm does. And honestly, that's one of my, as a scientist, it's one of my accomplishments was creating that algorithm.
This quite a bit. I think that it's interesting though how optimization is something that we do even unknowingly. And I guess what we're trying to argue for on this podcast is to say that, hey, if we only took a moment to kind of pay a little bit more attention to how important it is for us to understand, what game are we playing, what's the goal, and how are we optimizing to get there? I remember.
So when you say what game are we playing, you're saying what objective function are we optimizing?
What are we optimizing for? And I remember when Instagram first started out, it started out as an app called, I want to say it was called Bourbon or Burb or something. And basically what they did was you were supposed to do something weird where you went somewhere, you check in with your friends, And then it was almost similar to Square. I don't know if you remember Square from back in the day. Was it Square it was called?
That sounds
Or
familiar, but I don't know. I've never
yeah.
been. Yeah, I've never been too big
And
on.
I
Yeah.
think I can only just imagine what that company was like from then up until till now, because initially they came out and said, hey, we want to make an app that people can go on there and check in when they go visit somewhere and spot their friends or something like that. And so they put this app
Yeah.
out there, and they started to collect data on how people are using the app. And they realized that, okay, a lot more people just wanted to post their pictures, have people go like
Yeah.
it, and leave comments on it. So they started to optimize the app for exactly that.
Interesting.
They just, you know what?
Yeah.
Oh, this is what you guys want? Say no more. And they just optimize the app. Instagram, as it is today, was so far removed from the initial
From what it
idea
was.
that they came up with. This was just in the process of, and that's why it's so similar to how I work when I create like different brands or whatever, is I'm going through this painstaking process of restricting myself to this space of ideas to where I have to come up with an idea that works for a specific group of people, that will work on a specific kind of items, that will work in specific kind of colors. And I'm searching in this space, trying to come up with that singular one idea that can very, very accurately, reach the goal the client is trying to get to.
Yeah. And then you determine whether or not you've reached that goal based off observing the causal effect. Did you bring into existence what you're trying to bring into existence? Are more people using the app? And the thing about this that I want to tie is when you're saying that you're trying to search into space to figure it out. Like, one thing that I was thinking about when I was working on the isometric mapping algorithm was, your computer is this physical object, right? So no mentation without representation. Every state of the computer has to correspond to an actual different physical configuration of the computer. And so when my algorithm is searching in this space to find the parameters that give the correct answer, every time as the algorithm is making one step from one point to the next, the computer has to be changing its physical configuration from one state to another state as it's doing this calculation. And so if we're using the analogy of ourselves as computers, in the fact that the symmetry between ourselves and computers is, we know that as we are thinking or as we're doing something, we're going from one configuration to another configuration. That's the symmetry between us and computers. And so when you're actually thinking about trying to find a specific point in this space, when you're optimizing these functions, you are moving through the space of all possible configurations you can be in. There was a state of you before you solved the problem, and a state of you after you solved the problem. After you solved it, you went through a trajectory starting from point A, I don't know how to solve this, and then you moved along a trajectory until you slowly got to point B, and to where now you do know how to solve this, and you know what the answer is, and you're constantly trying to refine your approach at each step. And this is why we're trying to tie minds to algorithms. Because when you think about something like the adiabatic isometric mapping algorithm, and you think about the dimension of the space it's working in, think about the dimension of the space that all of the configurations we can be placed in. We can be placed in so many configurations. So this space is this huge dimensional space that you're trying to optimize in, given all these crazy parameters, and you're essentially just a computer algorithm making a step from one point to the other, trying to optimize whatever objective function you have. But the thing that's the beauty that differentiates us in a mind from the adiabatic isometric mapping algorithm is that algorithm cannot choose which objective function to optimize, and it can't choose the strategy it uses to optimize it. And because we can do that, the thing that differentiates us is we are self-reconfiguring algorithms. We have the capacity for self-reconfiguration.
And I think that it's important to know also that this space that we're talking about, we describe it as this vast space, but it really is that vast, and you can get lost in there. It's that literal, like you can get lost in there.
It's that literal. Yeah.
And I like to use the analogy of a crossword puzzle so much to kind of understand, what it means to like optimize for an objective. And if you are playing a crossword puzzle, there are countless number of words in the world. So the crossword puzzle then goes, you need 4 letters. So now all of
Yeah.
the words in the word now it reduced down to just 4 letters now.
To the set that has 4 letters, and you went from the set, the space of all words,
to the space of just the
to the space of all words with just the 4 letters, and that is a vastly smaller space to optimize in.
So you're optimizing in that space. Now here's the best part though. The best part is as you continue to go down, okay, I need 4 letter words that are synonymous with pirates, for example. You start going, ahoy or matey. You start going down that list. So,
I'm impressed. Are those even 4-letter words? I'm impressed if they are, because you really thought a lot about
5-letter words. Yeah, 5 letters. Yeah, all right.
Okay. I mean, they're mostly just sounds like onomatopoeia, so you can write them however you want.
And then you start going down this list, and you're in this space of ideas, just searching. Here's the part that is so mind-boggling and this came to me because I remember my first job. I worked at this company in Minneapolis, and shout out to anyone who's listened from Minneapolis. It was cold and I didn't like it too much, but I was out there and I was by myself for the most part, and I really got into crossword puzzles. And
okay, I see.
I really got into crossword puzzles a lot.
I did not know this about you.
And so I was working the night shift at the time, and night shift is a little bit more relaxed. And so I'll bring in my crossword puzzle book, and I would just sometimes yell out like the clues to see if anybody around me kind of knew what I was talking about or could help me out or whatever it is.
So what you would yell out the clues? Did they know you were doing
they
crossword?
knew that was what I was doing at my desk. So I would just be like, 4-letter word for pirate sound or something. And then, I started to get ideas.
Yeah.
This is so interesting because it always felt like a vastly different game from when I was playing it all by myself.
Yes.
That what that is just the fact that I was able to meet this other mind, and we're both optimizing for this thing together.
Yes. Yep.
And it is such an interesting thing for us to start to realize, like, how important it is for us to communicate with each other and build these composite minds, like we talk about, to where we can, just create this almost neural link, so to speak, share information, share ideas, solve problems together. And then when we detach, we each leave with an understanding of whatever we've achieved that day.
So I love that you brought this up, because it's a matter of so in this episode so far, we've defined minds. We're relating minds to these computer algorithms. And we're relating it to the fact that these algorithms, they affect the physical state of the computer. Because like I said, as the AIM algorithm is going from one point to another, the physical state of the computer has to be changing from one state to another. So what the algorithm does changes the physical state of the computer. And so what you essentially have when the algorithm is running is you just have this software that is causing this matter to change its state. And if you could see, I'm like wiggling my fingers around. That's, you can't see it. But the thing is if I take another mind, like Oyani was saying, and I put that person to come and they start communicating with me to solve that same problem. Now I have the matter of that person and the matter of myself. And as we're communicating, now you have that system as a whole is just changing from one state to the other as we're changing configuration. And so what you see is that as you continually add more minds, like another human, to solve this problem, it feels as though, something has fundamentally changed. But in all reality, you're just creating a composite mind. Like, all of that is a new mind. Like, the mind of Oyani and I talking to each other is the mind of Shannon and Oyani. That's a different mind than the mind of Shannon or Oyani. Because if I'm trying to solve a problem and I'm doing it by myself, I'm going to move through the space of configurations differently than I would if Oyani was there with all of his knowledge and all of his dynamics. Because now the algorithm of us together is going to have different dynamics than the algorithm of us by ourselves.
I agree. And it's definitely something that was so obvious to me when I used to play those crossword puzzles, because I really enjoyed being in a room with like 2 or 3 people who were, interested in, shouting out random ideas or answers, and then I'll try it out. Oh no, that doesn't work. And then eventually we'll hit on something. Sometimes it's not even a space of ideas that I even had access to.
You
Yes.
didn't have access to. You didn't. Yeah, because you didn't have the
No.
correlated information. And what that structure did not exist in you as yourself. And so, because this other person brings their dynamics along, they can now take you into
Absolutely.
space of configurations to where you couldn't go before. And then when you guys detach, you have the experience of traversing that space.
And it's
Yeah.
it's such an amazing thing to see. And I played this game for quite a bit, man. It really did keep me company back then. And oh
know that.
yeah, I was really into crossword puzzles at one point. And so just talking about optimization, it just really hit me that that's exactly what that was. And another thing that's interesting though is for like the both of us, for example, because we spend so much time together, because we have conversations together. I feel like we
Well, because our wives are sisters, and because at this point
we
we're
hang out together quite a lot.
we're brothers at this point,
And
so that's why we're always talking to each other.
I feel like we've ended up creating almost like when you go out and you see like a huge lawn, for example, a lawn like a piece of land, like a grass outside, outdoors,
yeah.
and then you can look on it and see where people just cut across after a time. So
yeah.
when two minds constantly communicate together, I feel like you kind of create that. You create something similar, like a pathway that is so familiar that that when we get together to like talk, we know.
Yes.
Yeah.
Gotcha.
And I think that's also one of the beauties about us being humans and how our minds function and being able to create those composite minds.
Well, it's crazy because we can create composite minds with birds and dogs and everything else. That's the thing. We can just go ahead and attach this to my mind real quick, and I have access to solving problems in a way I couldn't before. Like, speaking of which, with my job recently, I've been working on this problem that I've been talking about for the last couple episodes, and at this point, things are very interesting. It's always fun when you're doing something and then you're doing a calculation and something arises you don't understand, but you know that once you figure it out, it's going to be meaningful.
Yes.
There's something there. And so, and so the thing is I've been trying to solve, there's this one particular problem, I'm getting this result and I don't know what it is. And I've been just trying problem after problem after problem. Let me try this. Nope, that doesn't work. Let me try this. Nothing's working.
Don't even know,
and
dude.
So,
you don't know how similar this is to what I do. Like when I'm stuck trying to figure it, but I know there's something here. I just got to find it.
Yeah. Just gotta find it. And so what I've actually done recently is I started bringing in people within my my colleagues to come help. And I'm already given that I'm already having these different avenues of thought to approach this problem that I didn't have before. And it's just I need
ideas now that you didn't have before. And overall, what we're trying to get across is this is why it's important that we learn how to communicate with each other in a mutually beneficial way.
In a mutually beneficial way.
Because the amount of progress that we could make, and honestly, I don't think it's realistic for us to dream up some utopian society where everybody just gets along or whatever. But ideally, what we're trying to say is, how about a major part of your communication with people should be approached from the perspective of two minds trying to, optimally get to know each other, optimally trying to solve a problem, optimally trying to go someplace. Two minds are trying to benefit from each other so that at the end of the day, when they go when they go their separate ways,
ways, both of them leave having been in a better position than they were before the interaction. And you're trying to optimize the number. So when you're trying to determine which games to play, which objective functions to optimize, try to maximize the set of games you play in which both participants gain some advantage. You want to minimize how many games you play where when two minds couple to each other and start processing information, start going through the space of configurations, that one mind isn't purposely guiding the other one through the space so that at the end, that one's at a significantly worse advantage and that one's at a better advantage. And I think that when you look at us from the perspective of these information processors, because this process of thinking of minds as being these algorithms that are changing the configuration of this computer that is our physical system, when you think of it that way, then we're just trying to find a way to go from one configuration to another configuration. And whenever we rearrange reality, we're just trying to make some configuration over another configuration. So we're always just trying to process information. And as an information processor, if you're trying to bring a configuration into existence and make it stable, the worst case scenario is if you interact with another mind that is tricking you into processing information to put
Worst
yourself in a
position.
worse position.
Yes.
And so that right there, as information processors, should be our definition of evil. It is the worst case scenario. There is no scenario worse than to process information to constantly put yourself in a worse position than put yourself in a better
or
position.
to process information, or to interact with someone in such a way that your goal is to put that person in a worse position and you in a better position. Like,
Yeah.
yeah,
And you
I
in a better
understand that,
position at their expense.
we're not all gonna be roses and daffodils or whatever, but we should be
Yeah.
striving for a society where more and more of our interactions are mutually beneficial to both people. Someone comes up to me and
Yep.
says, "Hey, I need some branding work and logo work or some web design work." Yeah, I'm going to charge you XYZ amount of money, but I'm going to make sure that I am achieving the goal that you want. So that at the end of the day,
Yeah.
I
Yep.
benefited by you paying me. My work is out there. You
Yes.
benefited by also having something that actually legitimately works for what you're trying to do.
Something you couldn't create on your own, so you pay someone else, and so you get what you want, they get what they and everyone leaves hopefully happy. And I feel like that should be the like the new perspective on like the golden rule. Treat others the way you want to be treated. Instead, I think it would make sense to think of it as try to play as many games, or try to optimize as many objective functions that are less likely to take advantage of someone else. Like such that when you're optimizing the function and you're processing, you're doing the information processing, that at the end of it, both have been both participants, or all participants, are in a better position. And the thing is you don't necessarily have to make it to where your advantage and their advantage is the same. You might gain more of an advantage, but at the very least they've gained an advantage. Like, and if everyone is just playing these games with everybody else, to where we're trying to play as many games where everyone gains an advantage, then we can start working. It'll be easier for us to all create a larger composite mind.
That's the goal.
Then we have a larger composite mind. It can process more information. It can work toward a collective goal that we're all choosing to actively work toward that goal. One thing I was gonna say too is when trying to define this idea of minds, because people might be rolling their eyes at the idea that when I take like you and I together as we're communicating, that creates a new mind, that is the mind called Shannon and Oyani. That might sound like fluffy, like, oh, that's kind of trivial, it doesn't really mean anything. But when you actually think of yourself and how you are as a mind, you yourself are a composite mind in yourself. In other words, I'm trying to get at the idea of what it means to be an individual. And whenever you're trying to think of yourself as an individual, you are actually a composite mind that is the result of many smaller living beings functioning as one physical system. And so we know we have cells, we know we have like this bacteria, we know we have all these living things that interact in a specific way that give rise to different types of behavior. And depending on the settings of all that stuff, the representation of your mind in terms of how you program reality, how you go from one configuration to another, that's going to depend on the settings of all those things. And so as an individual, you are a composite system as yourself. So when we take another human and we add that other human to the mix, well, nothing has really changed. You're already a composite system as an individual made up of a bunch of living things. Now I just taken another living thing, and now they're interacting and their settings are correlated to each other as they communicate, and they're changing. And I don't really see any difference as I keep adding more humans to this mix, because minds themselves are already composite things. We are a computer made up of a bunch of living things.
I don't think it's something that people will listen to and kind of feel some type of way about it, because it is so obvious. I think the problem is that we just don't pay attention to how much we do this on a daily basis. Like, I play a lot of like multiplayer games online, or battle royale games where I get like two random people join me in a lobby that I don't know. And so we hop into this game and we know what the goal is. We are trying to stay alive till the end of the game and be the last team left.
Yep.
The best games
Apex?
that you would
talking about
play.
Apex?
Yeah, Apex. I'm talking about Apex Legends, by the way. I play that a lot. But at the end of the day, the teams that are successful are the teams that are able to create a composite mind.
Yes, exactly.
Yes.
Yeah, exactly.
Those are the only teams that are going to be successful. You have to, okay, this is what we're doing. This is what your your objective is. This is what your superpowers are. This is what mine is. Okay, so I have something that will make rockets shoot out of the sky, for example.
Yeah.
But if we're inside of a building, that's of no use to anyone.
Yeah.
Because we're in a building. So I have another teammate who has something that will work we need to create a composite mind to win. We do this all the time.
Yeah.
I just think people are just not paying attention to it.
Yeah. And I think that's basically what happens when we're being socialized. To be socialized is to teach how to create composite minds with other people.
Yes.
And I feel like one of the examples that I put in the outline was when I was younger. I remember my sister Catrice was pregnant with, I'm gonna assume was her youngest child, Tyra, and she was telling one of her kids, I'm assuming it was Adrian, I don't know, and she was telling her to hand her something, and so she was telling her to hand her something, and Adrian picked up the thing and then handed it to her mom, and so but from sitting on her couch, my sister changed the configuration of the universe from her not having that thing in the hand to her having that thing in her hand. And I remember sitting and thinking to myself, it's like, who was responsible for that change? Was Adrian responsible for it because she actually moved it? Or was it Catrice's command that started Adrian to actually move it? And that problem is really hard when you think of them as individuals. But when you think of while they're communicating, they were one composite system, it's like, oh no, the system of Catrice Adrian moved that thing. That mind did it.
We do it all the time. I think that the issue here is we're not paying attention to what it actually really means and how important it is for us to be aware of when we're doing it and why we're doing it.
Yeah, basically. Yeah. And so,
I think, the awareness is the big thing.
Yeah, so I think we have to be, we're getting toward the end. And I just want to point out that we are tying the idea of mind to the idea of computer algorithms using the principle of no mentation without representation, because there's a symmetry between computers and humans, and minds, of anything. It's not just restricted to humans, but computers and minds, that they are these things that you can place software on, and based off what software you have on it, it changes the physical configuration of the physical system. But the difference between us and, say, like software and a computer is that we have this capacity for self-reconfiguration. We can choose which games to play. We can choose the strategies we use. Because I didn't get into, like, in optimization, you can use gradient descent algorithms. You can use direct search algorithms. You can use Newton's method. Like, there are all these different strategies for trying to optimize this objective function. And basically, I think this is how we can tie minds to algorithms, is looking at the symmetries between us and computers, basically.
I think that I just want to say that overall, it's the idea that we're trying to communicate is that, we should be trying to optimize how we communicate. For example, we're these systems that constantly are searching in the space of ideas to, ideally anyway, move ourselves from, one position to a better position. Yeah. And we are able to do that if we can actually pay attention to, what are we even trying to optimize, and how we're going about it. And there is a whole lot of benefit with meeting another mind, creating a composite mind to where you are both trying to optimize for a specific, thing or function. Yeah. And, it really just makes everything just function better.
Yeah, like with us with this podcast, man, we both know what game we're playing, and we're both trying to optimize the game together. That makes working with you so much easier than if we were both going after some other goal. And if our goals diverge in some sense, then we start asking each
always
other,
take the pause. Yeah.
Why are our goals diverging? Just like at the beginning of this episode. Why are our goals diverging? Why? Yeah.
Because we're trying to say, okay, we're not really optimizing together right now. So, okay, let's take a step back. Yeah. Let's try to figure it out, tweak it, and then we keep going. So, I think this is something that every one of us can apply to our daily lives and just how we do things, because it will help us communicate better, interact better, and it will kind of create less of a shitty environment that we are kind of, feeling overall in the world right now. But, so
So
as always, guys, if you agree
let's
or
say
disagree,
do the plugs, yo.
oh yeah, I'm always doing the plugs. So as always, guys, if you agree or disagree, let us know. You can hit us up on social media. We are on Twitter, Instagram, and Facebook at the Bottom Turtle Podcast. We recently just started up a subreddit.
Oh yeah, tell them about that.
On Reddit, yes. The subreddit is the Bottom Turtle. We will be on there from time to time, to just chit chat with people who want to talk to us about stuff like this, and answer questions about the podcast and post some notes about the podcast and things like that. I think for me it was an idea that came up because I felt like I was on Reddit and I had a bunch of interesting interactions with people about the simulation hypothesis, for example. And so I was like, okay, yeah, I think Reddit might be a cool place for us to hang out and talk to people who are interested in stuff like this. So,
and that's the thing is, like, keep in mind, like, we don't want to just be like, if you think we're full of shit, please tell us, because we want good data so that we can optimize in the right direction. Like, we want that data.
Yeah. So, that back and forth, if you have any questions you want to use to test our hypothesis or whatever, bring them on. We are excited to do that and really, stress test a lot of these things that we think about a lot.
And keep in mind, remember, the purpose of the podcast is to create a language for conceptualizing, for, imagining the conceptual space. If we're all using the same language, then we have more mutual information. It increases the capacity for us to communicate with each other. And so if we can construct a language, if we can construct a language that is fair, like a fair language, and that's why we're tying everything to like physics, because in this process, you see that we're using no mentation without representation. We're trying to make our argument for why people should use this language from physical matter and how physical matter behaves, because it behaves independently of any individual. And so if we tie all of our reasoning to that, then we should be able to construct a fair causal language that everyone can use so that we can optimize that we can optimize our communication so that we can, solve better problems, bigger problems.
So hit us up on social media at the Bottom Turtle Podcast. Like, subscribe, tell your friends, man, share it. We're looking to grow this podcast, so we appreciate all the support, guys. And we will see you guys on the next episode. Until then, stay turtling,
my friends. Peace.
See you later.